Hello and welcome to our lesson on normal distribution and z-scores. So we're going to add to the topic of normal distribution that we started last time. So just to recap, normal distribution is distribution that is symmetric about the mean. So the picture sort of looks like this, where we said the mean, the median, the mode would all be the exact center. So that's exactly at the middle here. And then half of the data is below, half of the data is above, and the way that it falls below and falls above is symmetric. So those two halves of the graph would match up. And then further, we said that there would be 68% of the data lying within one standard deviation of the mean. So that if we added the standard deviation once and subtracted it once, that 68% of the data would be in that area. Or within that one standard deviation of the mean. And then we could cut this in half because it's symmetric, and we said 34% would be there, and then 34% would be there. And then we said there was going to be, this was the empirical rule, by the way, 95% of data within 2 standard deviations of the mean. So if I added the standard deviation a second time and subtracted it a second time, then we would have a 95% within that distance of the mean. And we said if we took away the 68 and cut in half what was left, we'd have 13.5% landing in this little region and 13.5% landing here. And then lastly, we said within 3 standard deviations of the mean would be 99.7% of the data, so almost all of it. So if I added the standard deviation a third time or subtracted it a third time, we would have 99.7% within that area. Okay, and then if we cut in half, well, if we subtracted out the 95 and cut in half what was left, we'd have a 2.35% here. It's really small, I'm sorry. 2.35% here. And again, that's 99.7% of the data lying within 3 standard deviations of the mean. Now, if we took that last little 0.3 that's left from the 100%, that give us 0.15% that would be outside of the 3 standard deviations. Okay, so that was our general concept of normal distribution, and then the empirical rule, which told us percentages that lied within exactly 1, 2, or 3 standard deviations of the mean. Now, these numbers down here at the bottom, the -1, 1, 2, 3, and actually we could put a 0 right here. At 0, we are at the mean. That means you're not adding or subtracting the standard deviation at all. Those numbers that I highlighted, those are what we call z-scores. So a z-score shows you how far, in terms of standard deviations, a given value is from the mean of your distribution. So for instance, if I said, let me put the 0 back. If I said z equals 1, z equals 1 means we are 1 standard deviation above the mean. So that is this location right here. So at z equals 1, the value is 1 standard deviation above the mean. And so if we're 1 standard deviation, if we're 1 standard deviation above the mean, then if we look at our graph here, we've got 50% of the data and another 34% of the data. That's 84% of the data is below or left of that spot. Okay, so 84% of, oh, went too crazy on the highlighting. There we go. So if we're 1 standard deviation above the mean, that 84% of the data lies below or left of that spot, which means there's 16% above that spot. Okay, 16% above that spot. Or, let's say I said, I was looking for z equals -2. Oops, that's not what I wanted. Z equals -2. That means that's right here, z equals -2, okay? That means we are 2 standard deviations below the mean. That means we have subtracted the standard deviation twice to get to that marker. So this would be 2 standard deviations below, okay? So the negative is telling me to subtract that standard deviation, go below the mean. And so if we're at this marker, okay, then we have 2.5% of the data to the left of or below that mark. So there's 2.5% below 2.5% the data is below that marker, which means the rest of it is above. The rest of it being, well, I swear, being all of this. So the other, what, 97.5%, because there's 100% total. So the other 97.5% is above or to the right of, I lost a word here, to the right of, oh, I think I did that up here. Oh, maybe not. Whatever. Sorry. Okay, so z-scores tell you how far in terms of standard deviation you are from the mean. Now, if we have a problem where, let me show you an example. Okay, let's say that, what were we looking at before? The weights of newborn babies. Let's say that the mean was 8 pounds and the standard deviation was 1 pound. We could make a normal curve for that situation. Okay, and we again put our mean in the middle, and then we would add and subtract our standard deviation. So if we added our add and subtract that standard deviation. So add it once and twice and 3 times, subtract it once and twice and 3 times. That here we'd have at 8 we have a z-score of 0. We're at the mean. We haven't subtracted or added the standard deviation at all. At 9 we'd be at z equals 1, and then at 10 we're at z equals 2, and then at 11 we're at z equals 3. That means we've added the standard deviation once, here we've added it twice, here we've added it 3 times. And then if we subtract it once we get to 7, subtract it twice we get to 6, subtract it 3 times we get to 5. So again, these are our z-scores. Okay. Now, again, we have the empirical rule, which told us percentages to the left and right of those exact places. Okay. The issue is, what if we have a z-score that isn't exact? So if I said, what's the percentage of babies that weigh less than 9 pounds, no big deal. There's 50% here, there's another 34% here, so we could say that 50... Let me not try to write that with highlighter. We could say that that 50% and that 34% would be 84%, right? There's 84% of babies that weigh less than 9 pounds. Okay, that's not too huge of a deal because that z-score is exact. But what if I said, or what if I asked, what are the percentage of babies that are weighing less than, let's say, 8¼ pounds, 8.25 pounds. Okay, if I'm at 8.25 pounds, then I'm going to be like here somewhere, and I can't use the empirical rule to find the percentage less. Now, I know it's going to be more than 50%, right? Because I've got 50% over here and then a little bit more, but there's no way for me to determine exactly what that percentage is going to be. So we're going to have to use technology when our z-scores are not exact. Fortunately, Desmos is some technology that can tell this to us. It can show us exactly the percentages that are left of or right of or even between, if I wanted to go between, any z-scores, any values. Okay, so Desmos can tell us percentages of data that are less than, greater than, or between any z-scores. Okay, so it would give us the exact ones too. So if the empirical rule is not something that you want to commit to memory, you don't have to. Okay, so what we're going to do is from Desmos, and I took a little screenshot here. From Desmos, we're going to go to Functions, and then we're going to click on Distributions, and then we're going to be looking for Normal Distribution. So from Desmos keyboard, you go to Functions, and it may be abbreviated if you're on your phone. And then you're going to go to Distribution at the top, and then you're going to choose Normal Distribution, and it says Normal Dist. Okay, that's the abbreviation for normal distribution. Like if you're going to abbreviate, you might want to cut off a little more than that, but whatever. Okay. And then what we're going to do is when you click normal distribution, this is going to pop into the screen. There's a couple more things you want to press. You want to hit this little, looks like a magnifying glass. That's called the zoom fit button. So press the zoom fit button, and that's going to allow you to see this entire curve. Okay. The normal curve. It's going to basically draw it out for you. And then you're going to click the box to select C, D, F. So that is this box right here. You want to click that box to find the cumulative probability. And that is going to give you this in your Desmos screen. Okay, so you'll hit that zoom fit button, you'll click that little box, then you're going to see a negative infinity and a positive infinity. And right now it says 1, because if we go from negative infinity to positive infinity, what we have captured is 100% of the data, and 100% is given as 1. But what we're going to be able to do is change our max and min to identify percentages left of, right of, or between any z-scores. Okay, let me just clean up this mess I've made here. And alright, so let's see if we can try this out. Okay, let's say we want to find percentages, and these percentages, remember, are probabilities. Probability could be given as a decimal, a percent, or fraction. So when we're finding a percent that is less than a z-score or percent right of a z-score, that's the probability that someone falls in that region. Okay, so if I say find percent or probability, I'm asking for the same thing. It's the percent. Now, if we're going to look at some generic normal distributions, that means we don't have a specific set of data in mind. There's no exact mean or standard deviation. This would just be generically, in any normal distribution, what percentage of data is left of, right of, or great or between any z-scores. Okay, so just generically, if we want to find the percentage of probability of the percentage or probability of data that is less than or left of, those mean the same thing, less than or left of a certain z-score, what we're going to do is we're going to leave the minimum blank, and it will actually populate a negative infinity in there, but you'll just leave it blank and it will take care of that for you. And then we're going to enter the given z-score for the maximum. The given z-score for the maximum. So let's do this. Let me show you. So in Desmos, again, we're going to go to our keyboard, hit the functions button, go to, you could be in one of these places, I don't know, but we're going to go to distribution, and then you're going to select normal distribution, and that pops the normal distribution in your screen. Now this is generic. Now see how the cursor is hovering into the parentheses there? This is generic, so I don't want to put anything in the parentheses just yet. I'll show you how to use that in a bit. For now, what we want to do is press the zoom fit button, and now we can see our normal curve, and then we're going to click the little box here to find the cumulative probability. And there's our normal curve, and again, we have this 1 here because we have 100% of our data highlighted. Now, what if I wanted to find the percentage of data, or the probability that data lies left of z equals 1.51? So 1.51 left of that. What we're going to do is we're going to leave the minimum blank, and in the maximum we're going to put that z-score of 1.53, and now we can see in our picture here 1.53, and all the stuff left of it or less than that z-score is now highlighted, and then below in our box it tells us what percentage that is. So I can see, so we can hover here. No, it won't let me hover. I can see in the equals 0.93699, whatever, that is the percentage of data that is left of that particular z-score. Okay, now just so you can see this again, let's say I put my max at 0. If we were at the mean, we know that's 50% of the data. That's what that's telling us here. Or if I was at, let's say 1, a z-score of 1, we said that'd be 84% of the data left. Okay, if we know an exact z-score, we can use the empirical rule, or again, if you don't want to commit that to memory, you can put that in here. But if our z-score is 1.53, I don't even know that percentage, I can use Desmos to find it. So 0.937-ish is our decimal. So this is 0.93, let's go yeah, let's go 937-ish, which is going to be 93.7%. 93.7% of data in normal distribution would be left of or less than a z-score of 1.53. So no matter what your distribution is, whatever your mean is, whatever your standard deviation is, if it's normal distribution, there will be 93.7% of data left of that z-score. Okay, let's put another one. What if we want to know what's left of negative 2.2? Now let's change our maximum here to negative 2.2. This isn't going to be very much data because negative 2.2 is very far to the left there. But let's go ahead and put it in. Negative 2.2, not 22, 2.2. And there it is, really small decimal. So this is about 0.0139. We can even make this how much decimal you keep is really up to you. Let's go ahead and leave the 39 there. So this is going to be 1.39%. If you had rounded that to 1.4%, that'd be okay. And remember, if you want to convert your decimal to a percent, you can just multiply by 100. So if your decimal is 0.0139 and you multiply by 100, you're moving the decimal twice, basically. But if you want to use your calculator, just multiply by 100. So 1.39%. So we can see that little tiny sliver, that little tiny 1.39% is highlighted over there. That is the percentage of data that is to the left of that particular z-score. Okay? And again, this is generic. Now, what if we want to find the percentage to the right of or greater than? If we want to go to the right of or greater than, let's say greater than first. If we want a percentage greater than or right of, those mean the same thing, a specific z-score, then this time we're going to enter the z-score in for the minimum, and then we're going to leave the maximum blank. And we're going to leave it blank. It's going to automatically put an infinity in there, but we don't have to worry about what we put into that spot. Okay? So right of, if we wanted to know how much was right of, let's say, the mean, right, I could leave this blank and I could say a z-score of 0, okay? That's how much of the data is right of the mean. I can see it is 50%, okay? And I can find any exact z-score using the empirical rule, but z equals 0.93, I have no idea. So if I put in 0.93 here, I can see from my picture now what's highlighted is the percentage of data that is to the right of that particular z-score. So in our box we can see that that is 0.176-ish. So we're going to say 0.176, which is, I guess we can use an equals here. We can use an equals here, which is 17.6%. So 17.6% of the data. And then how about negative 2.84? That's going to be big this time because that's way to the left. Negative 2.84. So negative 2.84 is almost all of it, right? Negative 2.84 is way over here. We can't even see it. How much is to the right of that? It almost looks like everything is shaded. If we zoom in a little bit, you can see the negative 2.84 is the cutoff. There's only a tiny little sliver that's not to the right of that value. And that's why our percentage is so high. So this is 0.998 or 99.8% of the data that is to the right of that particular z-score. No matter what the data is, if the distribution is normal, there will be 99.8% of data to the right of that particular z-score. Okay? Now, if we want to go between, if we're going to look for a percentage of data that is between two z-scores, then we don't have to leave the max or min blank. We're just going to put the smaller z-score in for the min, put the larger z-score in for the max. So the smaller z-score goes in for the min, and the larger z-score goes in for the max, and it's going to tell us the percentage of data in between any two z-scores. Okay? Now again, if this was an empirical rule problem, let me fix my graph here. If I wanted to go from one standard deviation below to one standard deviation above, we already know that the empirical rule tells us that's 68% of the data, and that's confirmed there. Or if I wanted to go 2 above and 2 below, that's 95% of the data. That's what the empirical rule said, right? But if our z-scores aren't exact, then we can't just use the empirical rule to state that, oh, that's 95%. So if they're not exact, then we're going to enter these in Desmos. So let's go here. Between negative, it's going to be a small amount. This is a small area here. Between negative 1.41 and negative 1.75. And negative 1.75 is smaller, so I'm going to put that there. And then negative 1.41 there. And that little sliver of the graph is the percentage that is between those two z-scores. So that is 0.0392, which is 3.92%. Okay. And then here we're going to have a much larger area because we're going all the way from negative 2 to 3. So if we have our minimum at negative 2.01 and then our maximum beyond 3 here, so 3.28, we can see that there's a whole bunch of the graph that is between there. And if I try to zoom in, you can barely see over there the cutoff, okay? But that's a whole large chunk of the graph that is between those two z-scores, which is why we have this decimal, 0.977, or 97.7%, which is a pretty large percentage of our data. Oops. Okay, so there's that. Now, if we try to get a little more specific, then we might want to know the z-scores for our data when it is specific. So, for example, let's say that or if the z-scores for our data are not exactly 1, 2, or 3, and we want to be able to calculate a z-score for data that is specific, we have a formula to calculate a z-score. So z-score is going to be equal to, we take our data, whatever it is, we subtract the mean so we can find the distance, and we divide it by standard deviations. So what is the standard deviation? And it's going to tell us exactly how far we are from the mean in terms of those standard deviations. Okay, so for example, let's say a normal distribution has a mean of 50, so I know 50 would go here, and a standard deviation of 5, so I can add 5 once, add it twice, add it a third time. I can subtract it once, subtract it twice, subtract it a third time. So this would be a z-score of 0. This would be a z-score of 1 and 2 and 3. And minus 1, and minus 2, and minus 3. Okay? So if I said, what is the z-score for 55? Well, the z-score for 55 is 1. 55 is 1 standard deviation above the mean. So z equals 1 for 55. I don't need a formula to do that. Okay? That was green. If I said find the z-score for 40, okay, z-score for 40, well, I see exactly where 40 is at. 40 is exactly 2 standard deviations below the mean, so we can say our z-score is a negative 2. Now, if it's not exact, like 43, let me use a different color here. So if I wanted to find the z-score for 43, well, I know 43 is going to be between negative 1 and negative 2, but I don't know exactly where it's at, so I'm going to use my formula. So the z-score for 43 says take the data, which in this case is 43, subtract the mean, which was 50, and divide by the standard deviation, which was 5. And we're going to figure out that 43 minus 50, that whole thing divided by the standard deviation of 5 is negative 1.4. And that should make sense, right? We knew the pink there was got to be between negative 1 and negative 2, and now we know exactly that it's at negative 1.4. Okay? And then similarly, what can we use here? Orange, if we wanted the z-score for 56, 56 I know is going to be a little bit after 55, and so I know my z-score, that's terrible, is going to be between 1 and 2, but I don't know exactly what it is, and so I can use my formula. So the z-score for 56 says take the data, which in this case is 56, subtract the mean of 50, divide by the standard deviation of 5, and now I can just change this to a 56. and it's 1.2, which makes sense. Okay, 1.2. So I can use that little formula to find z-scores so that I know exactly where any value is. And I can also take this specific data, and just like I was able to find percentages of data left, right, and greater, or left of, right of, and between any z-scores, so generically in Desmos, I can also find amounts of percentages of data left of, right of, or between specific distributions. Okay, so let's go one more example here. If I wanted to find for specific data, if my data is specific, so if I actually know a standard deviation and I know a mean, and I can find the data, the percentage of data left of, right of, or between anything in that case too. So what we're going to do is for normal distributions in Desmos, for specific normal distributions in Desmos, then after the normal dist thing in the parentheses, we're going to put in the parentheses the mean separated by a comma with the standard deviation. STD is not a good standard deviation. And I don't know why I made that blank so small. Okay, so then you could find probabilities, again, less than, greater than, or between specific values this time instead of z-scores. So when it was generic, we were going left of, right of, and between z-scores. And then now that it's going to be specific, we're going to go left of, right of, or between the actual values. Okay, so let me clear this out, show you again what we're doing. So we have, this problem connects with this problem, and I did not bring it over. So we have this, it's the same normal distribution with a mean of 50 and a standard deviation of 5. And this is continued from the previous problem. Sorry guys, I didn't realize this spilled over to the next page. So we had a mean of 50 and a standard deviation of 5. Okay, so if we have the specific information when we go into Desmos, again, we're going to go into our functions, distributions, we're going to select normal. Now, instead of leaving the parentheses blank for a generic situation where we use z-scores, we want specific information now for specific values. So what I'm going to do is put in my mean first, which was 50, and then a comma, and then my standard deviation, which was 5 for this specific situation. Now I still want to press my zoom fit button to get my curve, but now you can see on the bottom, instead of just generic z-scores, we actually have values there. And then I still want to click on the box to find the cumulative probability. So now, let's say I wanted to find the percentage of data that was to the left of 55. Left of 55. Well, 55 is not a z-score now, it's an actual value, but I'm doing the same thing, where left of 55, I'm going to make 55 my maximum, and now I can see, right, there's 55 there. I have highlighted the percentage of data that is to the left of that mark. And in my box, it tells me that is about 84%. So this is 0.841, 0.841, which is 84.1%. Okay, or let's say less than 40. Less than 40, let me put 40 in as my max. Okay, 40 is 2.27-ish%. So this is 0.0227 or 2.27%. And 2.3% would be fine, so wherever you're rounding there. If we want to go right of, then we're going to make the minimum our value, and we're going to leave the maximum blank. And now I could see it is highlighted from 43, and then everything right of that is highlighted. So that percentage that is to the right of 43, that value of 43, is 0.919, so 91.9%. And then greater than 56, again, I'm going to make my minimum 56. and I can see from 56 on everything is shaded there, and that is 0.115 or 11.5% of the data. And then again, if I wanted to go between, then I'm going to put my smaller number 40 and my larger number 55, and it'll show me that there's about 82% between those two numbers. So this is 0.81. Let's see, 81. After the 8, the second 8 is a 5, so I'm going to make that 819. So 81.9% between those two marks. Okay? So Desmos is really doing all the heavy lifting for you. What you just have to be careful with is if we're looking for percentages of data left of, right of, or between z-scores, that's just generic normal distribution. There's no data attached to it. So we use the z-scores in Desmos as our maxes and mins. And then if we're in specific normal distribution, that means we know the mean, we know the standard deviation, then we input those, and instead of putting z-scores for the maxes and the mins, we use the actual values for the maxes and the mins. Okay, so hopefully you've got enough to get you started with your practice, and as you work through it and practice a little on your own, hopefully you'll become a little more fluent in what's happening. But if you need some extra help, as always, reach out. I am here for you. All right, guys, take care.